Okay, Assalamualaikum. So now we look into subtopic 3.6, that is optimum depth non-full flow for closed conduit. So maksudnya kita ada satu closed conduit. What is closed conduit? It is a pipe, okay? And then we have the non-full flow. Maksudnya air yang flow rate dalam pipe tu hanya separuh je level. Okay, macam dalam figure ni. Okay, kita ada pipe and then maybe dia punya level of water half or ataupun suku, okay, atau maybe almost 90% saja yang full with the water. Okay, so we will look on how to determine the area of this and then the depth of the water, okay, in this closed conduit. So for a circular part with steady and uniform flow, okay, bear in mind it is applied to the part with steady and uniform flow shown in figure 3.11, okay, previous figure here. The flow cross-section area A can be determined as follows. So A equal to sector OMNP minus triangle OMP. So meaning that we have the closed conduit here, and then we have the flow level water here. Okay, so this is we symbol as O. Okay, so this is M, O, M, and P, right? Okay, so the level of the flow is flow rate. Okay, I. Okay, so how we need to determine the radius and then also the depth of the water. Okay, so we will apply the area for the sector OMNP. Sector OMNP is, okay, so kita tengok sector OMNP is the rest, the full, this one, minus the triangle OMP. Triangle OMP is this one. Triangle kan, segitiga. Okay, so yang green minus blue, so we will get the red area. So formula, what is the formula for sector OMNP here? The green, okay? The green is, okay, from the formula. So memang dia dah ada formula untuk sector OMNP ni, yang green area ni. Okay, so yang green line, yang green boundaries ni, nampak? So the formula is half R square times with 2 theta. 2 theta. So where is your theta? Theta is, okay, kita ada satu theta kat sini. So apa? Okay, so nampak theta here, 1 theta, and then the other is theta 2. Okay, so that's why we have 2 theta. Okay. Okay, so area for a sector is, okay, wait, for the full area for a circle is, area for the half full circle is pi r square, right? How about area for a sector? Area for a sector. is, okay, area for a sector theta. So theta means area untuk sektor yang ada theta. Sudut theta is half of the theta times r square. Okay, so therefore kita nak sektor OMNP. Therefore kita ambil lah formula ni, half, okay, half ni, half r square. But we have 2 theta. So we put theta 2 kat sini. Okay, 2 theta. Sebab ada 2 theta. So that is area for sector OMNP, green boundaries tu. Minus triangle OMP. Triangle is the blue, right? Yang ada lorek blue tu, nampak ni? Saya tak nampak, saya lorek lagi ni. Okay, blue this one. So, kita punya formula untuk triangle is apa dia? Okay. Formula untuk triangle. Okay, formula untuk triangle, we know that we have x, okay, x times with y, kan? So, x times y, okay, so we have sin theta equal to x over r. Kenapa over r? Sebab r kat sini. Okay, so kita akan gunakan formula sin cos tangent, So, since we have theta dekat ni, so yang opposite with theta is x, over hypotenuse is r. Okay? And then again, kita tak tahu y, kan? So, y theta equal to, cos theta equal to, okay, cos is adjacent, y over r, right? So therefore, x times y, right? So calculate area for triangle is x times y. So r ni kita akan letak depan lah. So x times y, x is r sin theta, okay, times with, okay, y, kan, y is r cos theta. So that is area for triangle. So kita simplifikan dia, so we get r square sin theta cos theta. Okay, so ini lah yang kita masukkan dalam triangle OMP. Sebab apa kita tak perlu divide 2? Because we have 2. Okay, kenapa kita tak perlu divide dengan 2? Sebab this is kita ada 2 triangle. So bila dah ada 2 triangle, means we have 1 square lah. Okay, so that's why lah kita tak payah nak divide by 2, sebab nanti kita nak kena times with 2 balik semula. So therefore kita tinggalkan je in r square sin theta cos theta. Okay, so we get this, and then kita pun boleh lah simplify all this. We get r square times with theta minus half sin 2 theta. So that is area yang apa? Yang berlorek merah ni. Yang berlorek merah ni. This area yang covered with the water. Okay. Next, we have A, and then we need to calculate the P. Okay. P is the whole perimeter formula okay. So the whole parameter we know P equal to 2 pi r. So if we want to determine the perimeter for the sector theta, okay, we need to determine this. Okay, let's say we symbol it as S, and then this is theta, and then this is your R. Therefore, S is R times theta. Okay, so 2R theta. Therefore, we have the perimeter is 2R theta. Sebabnya kita ada dua sektor theta tadi kan. Okay. So kita ada ni theta satu and then theta 2. So we have S here, S1 here, S2 here. Therefore, kita kena ada P is kita times with 2. So 2R. So we know that when under optimum condition, the flow rate is maximum. Okay. Therefore, we need to differentiate the A over P to the theta. So we simplify this one, and then we will get this equation 3.22. By substituting the equation 3.2 and 3.21 into 3.22, you will have equation 3.23 here, and then you will get the theta is 128.75 degree. Hence, the depth of the flow at maximum can be calculated by D equal to R minus R cos theta. So we get D equal to 1.62 R or 0.81 diameter. D is diameter, small letter D. Okay, D is the diameter. So the depth of the flow, okay, we know that this D. Okay, depth of the flow is 0.81 diameter. By using the cheesy, so we put into the ACMI square root. So we get A over P here, and then kita pun simplify this equation, and then for a given C and I, the maximum discharge occurred when A3 over P is maximum. So we differentiate this equation. Okay, A to P to the theta, and then you will simplify this one, you get equation 3.24. Okay, by substitute the equation 3.2 and 3.21 into equation 3.24, you solve it, and then you get the theta 154. Hence, during the maximum discharge, so you get the D is 0.95 diameter. Okay, so that's all for to determine the maximum optimum optimum geometry for the maximum discharge.